All right, algebraic reasoning. We are taking a test on Friday. So today we are reviewing, and this is the review video going over the entire review from the Go formative. So that way we can get some additional notes, some review, some tips and hints on how to be successful on your test on Friday. Your test will look very similar to this review. So you want to make sure you understand this review. You might need to play it over a few times. But if you go to goformative.com, okay, you're going to see um, your review. Okay, so you're going to look at these questions, answer them on the right, and what we're going to do is I'm going to do the answers on this whiteboard. Whoops. And then we'll transfer over the answers. Okay, so let's zoom in here. All right, so number one says Poster Maloney has $500 in his checking account, but plans to withdraw $30 each month to pay his phone bill. Which function represents the balance of his checking account B after X months without considering other withdrawals? All right, so let's think about this. Mr. Poster has $500, right? So that is what he starts with. That's his B beginning. That's like a Y intercept in a linear equation, okay? But notice how it says withdraws $30 each month. This can confuse people because they don't know if they're adding or subtracting, but doesn't withdraw mean to subtract, okay? So you've got your $500, okay, and you're subtracting $30, and then it has this very key word. It says each month, okay? I'm gonna underline each month. Anytime you see the word each, that is basically saying multiplied times X, okay? Each month means times X amount of months, okay? So this is minus 30, not just one time. It's not just minus $30, it's minus 30X, and the X is each month, an unknown amount of months, okay? So that can help us get our equation, right? We start with $500, and we're withdrawing $30 each month. That's my X. Each month is X. And you know that because it says right here, X months. Okay. And I guess I will change this a tiny bit. Instead of using Y, usually we use Y, it says that, hey, we're looking for B, the bank money. $500, take away 30 each month, X. So our answer, it's not A because it's not exponential, okay? It's not C because we're not adding $30 every month. We're not making $30 every month. We're withdrawing it, okay? And look at letter D. They've confused where to put the X on letter D. Okay, it's very important that the X goes where you see the keyword each. Okay, so the answer has to be B. Okay, so go back to the formative for number one and put B. All right, let's look at number two. Little nose X. Notice that the population of bacteria in the culture that he was studying started at 300 and doubled every day. You all know double means times two, right? Okay, so does this situation represent a linear relationship? If so, which function can be used to find the total number of bacteria T after any number of days D? Okay, so and you know what? Probably should have put an X there because there's no letter D in the equations. But either way, it says remember double means by a rate of 2 times. Okay, now how would I do this? Okay, I know double means times 2, right? But remember, when we're talking about linear equations, that's adding the same amount each time. Adding the same amount each time. That's what linear is. Not multiplying the same amount each time, okay? So if you're doubling every day, that's not linear, okay? So double is multiplying And multiplying is not linear. It is exponential. And I'm sorry, this looks super ugly because I have to write on my laptop. Okay, so A, B, and C, none of those will work, okay? Because it's not adding or subtracting each month or each day, sorry. It is actually multiplying by 2 each day. So this is what we would say, not a linear function, okay? Not a linear function. If you are multiplying by a number each day, that is not linear, that's exponential, okay? All right, let's look at number 3. Does the data set in the table below show a linear function? If so, which function represents the data? All right, let's pick it up. Now, the way we tell if this is linear is we're going to do the common differences. We're going to do what I like to call bird beaks on the side. We're going to find out the difference and see if it changes by the same amount each time. Okay, so start with the y's on the right hand side. 2 up to 5 is 3. 5 up to 8 is 3. 8 up to 11. So that's the same. On the x side, 1 up to 2 is 1. 2 up to 3 is 1. 3 up to 4 is 1. Okay, so this is linear. Okay, as long as those common differences are the same all the way down, that's linear. Great. So D is wrong. So now A, B, or C. All right, so remember the slope. Now this little triangle means change in y over change in x, which is a fancy way of saying what's in the bird beak of the y on the right hand side over what's in the bird beak on the left hand side. Okay, so my slope is going to be 3 over 1. Cool. So I know that when I write my equation, y equals mx plus b, my slope is going to be, my m is going to be 3 over 1, which is the same thing as just saying 3, right? Okay, so I can find my slope doing the change in y over the change in x. That's 3 over 1. Okay, now plus b. Now my y-intercept is when x is 0. Okay, so my b is the y-intercept when x equals 0. So now look at your table. Where is x 0? It's not, right? So I don't want you to tell me the y-intercept is 2 because that's not when x is 0. That's when x is 1. So we've done this before, and it was in the notes, but you need to go back down to 0, okay? So on the left side, I had to subtract 1. So on the right side, I'm going to have to subtract 3. 2 minus 3 is negative 1. And I know that's ugly, and I'm having to write on top of stuff. But do you see what I'm doing there? I have to go back to when x is 0 to figure out what the y-intercept is. The y-intercept is 1. All right. So my equation is going to be y equals 3x minus 1. And that would be letter B. Okay. So I know this looks ugly at the end, very complicated looking. I'm just trying to make as many notes as possible so you know how to tell if it's linear. If all of the common differences are the same from the bird beaks, then that's linear. Then you can find slope by putting the change in y over the change in x. The bird beak numbers on the right over the bird beak numbers on the left and reduce it. That's your m, that's your slope. And then for your b, your y-intercept, you have to make sure x is 0, what is y? And like this one, you might have to go back to 0 to figure out what your y-intercept is. 3x minus 1. So number 3 on the review is B. So 3 was B. Oh wait, I didn't write down number 2. What was number 2? 2 is D, sorry. Let's put that down here too. And then we'll move on to number 4. Okay. All right, so on number 4. So let's look at the table below, which is the following represents the function model generated by using the average rate of change slope. So once again, we are gonna, it's just like the one we just did, except the table's sideways. Okay, so let's do these bird beaks. Okay, negative 2 up to 0 is 2. 0 up to 2 is 2. 2 up to 4 is 2. 4 up to 6. All right, and then what about the top? 0 up to 1 is 1. 1 up to 2 is 1. Hey, look at that. Okay. So this is linear, I can tell, because all the common differences, all the bird beak changes are the exact same for each side, right? So remember, slope is the change in y over the change in x. So remember, change in y on this, in this case, it's going sideways like this. Here's your y on the bottom, right? So it's going to be 2 over, and my change in x is going to be 1. 2 over 1, which is just 2. So now I know my m is 2. All right, now what's my b? So m equals 2. My b, my y-intercept, is when x is 0. Now where is x 0? Well, I can see right here when x is 0, right? So when x is 0, the y is negative 2. So my b is negative 2. So on this one, I didn't have to go back one more. X equal, the 0 for x was already on there. So I'm telling you, sometimes it's already on there. Sometimes you got to go back one. Okay, just you got to look at your table. Cool. So if my m is 2, my b is negative 2, y equals mx plus b is going to be y equals 2x minus 2. And my answer is going to be letter A. So let's go to the go formative. Put letter A for number 4. Okay. All right, on number 5, use the data table, select the most accurate statement. All right, so we got a lot of information here. So is this linear? Okay. So let's do this. 2 to 0 is negative 2. 0 to 0 is 0. 0 to 2 is 2. 2 to 6 is 4. 6 to 12 is 6. 12 to 20 is 8. All right. And then on the whole left side, it's going up by 1, 1, 1, 1, 1, 1. Right? Okay, now you tell me. Are these changes the same on the right and same on the left? Well, on the left they're the same, on the right they're changing. So like negative 2 over 1 is not equal to 0 over 1. They're not equal. So if the rate of change is not the same each time, then guess what? No, this is not linear because it's not a constant rate of change. It does not give you the same ratio, the same rate of change for each set of points. Okay, so this is not linear. That's how you can tell if it's not linear. If your rate of change is not equal, or if it doesn't even reduce to being equal. Okay, so 5 is C. All right, number 6. Okay. All right, using the data table below, select the most accurate statement. All right, so let's find out if this is linear. So once again, we're going to do the bird beaks. 5 up to 7 is 2. 7 up to 9 is 2. 9 to 11 is 2. 11 to 12 is 1. Okay, on the left side, 2, 2, 2, and then 1. Now, they're not perfectly the same, like all the way down one side and all the way down the other side. But here's what matters, okay? If I do, again, change in y over change in x, right? So if I take the first bird beaks on the left and the right, that's 2 over 2, right? Now I know 2 over 2 equals 1 over 1, right? And then if I do the next pair, left and right, 2 over 2 is 1. I do the next pair, 2 over 2 is 1. And then at the bottom, if I do 1 over 1, well, 1 over 1 is obviously 1 over 1, right? So actually every single bird beak is equivalent because they reduce to the same fraction. So this is linear, okay? So my slope is 1. Okay, so it can't be C, it can't be no. And I see that which one says slope of 1 is letter B, right? Let's look for that y-intercept. When x is 0, y is 5. So my y-intercept equals 5. And then my slope equals 1. So which answer is the best? Well, the data in the table is linear with a y-intercept of 5 and a slope of 1. That would be letter B. All right? So let's put that down. All right, let's look at number 7. All right. Billie Eyelashes saves money to purchase birthday presents for her little brothers and sisters. She already has $30 in her saving account, plans to deposit $10 every 2 weeks out of earnings from her new after-school job. The graph shows a linear model for Billie's savings based on the number of weeks she has been depositing money from her after-school job. How many weeks will Giselle need to have worked? Billie need to have worked in order to have saved $70, okay? So you see how she starts at $30 right here? And then she $10 every 2 weeks. So up to 10 is 40 bucks over 2 weeks. Hey, up 10 bucks over 2 weeks. You get the idea. So when does she have saved 70 bucks? Check it out. Let me zoom in. Oh my gosh. Let me just zoom in there. Thank you very much. So 70, if we go straight over and then go straight down, how many is that? Well, that would be 8. Okay, 8 weeks, she will have $70. All right, so you can use that little graph. So B. All right, let's try number 8. All right, here we go. So find the slope of the line. Now please remember, slope is, for on a graph, rise over run. And remember, y, a rise is up and down, which is y, over run, which is left and right, over x. Okay. So pick 2 points, and then you're doing it like you read from left to right. So I'll pick 2 points here, right here, and right here. Okay. Now, like I said, like you're reading, you start at the left, go to the right. So starting right here, I rise. A lot of people would say, oh, Mr. G, you rise too, right? Well, hold on. I'm rising down. When you rise down, that is negative. Negative 2. and then run to the right. Anytime you run to the right, you're positive. That's great. Okay, but if you rise down, that don't make sense. Rise down, but that's negative. Okay, so our rise over run is negative 2 over 1. Okay, and so our answer for 8 is 8. Let's write that down. Okay, next, let's find the slope of this line. Same thing, we're going to do rise over run. Now we already got 2 points here. I'm going to count. Rise 2, starting at the left to the right. Rise 2, up is positive. To the right is positive. Run 3. So my rise over run equals 2 over 3. So I should get letter D. One second. Sorry about that. So back on track here. So that was number 9. Look at number 10. Find the slope and y-intercept of the graph of the linear equation. So check it out. Slope is m, y-intercept is b, and remember it's y equals mx plus b that we're looking at. So if it's y equals negative 3x plus 5, then my slope is negative 3. My y-intercept, my b, is positive 5. So slope is negative 3, y-intercept is positive 5. That will be letter D. 10D. Okay. 11, a linear equation written in the form y equals mx plus b is in what form? Okay. Now m is slope, right? And b is a y-intercept, right? So slope and an intercept. This form is called slope-intercept form. So 11 is B. Okay. So again, y equals mx plus b is slope-intercept form. Last but not least, which of the graphs has a line with a slope of 2 and passes through point -1, -6? First, let's look for that point -1, -6. So it looks like A does not have that point. Looks like B does not have that point. Okay, C has that point, and then D does not have that point. So it looks like there's only one answer right now. Let's double check that slope. And I'm gonna have to really zoom in on this. Is this slope 2 over 1? Up 2 over 1. Up 2 over 1. Up 2 over 1. You know what? It is. It's 2x. 2 is the slope. -1, -6 is the point that's on it. So for number 12, the best answer is letter C. Okay. On your test, read it carefully. It's not the same exact question. Okay. So 12 is C. Okay, so you finished your review. Your test is just like this. You got to know how to do this stuff. I'd re-review this stuff before your test. You can submit your review now. And that'll be it for that. So again, make sure you know this stuff on this review so you can be successful on your test on Friday. All right? See you then.